In biochemistry lecture, we see amino acids, lipids, carbohydrates, and enzymes, in which glycolysis pathway, TCA, tricarboxylic acid pathway, citric acid Krebs cycle, gluconeogenesis, Cori cycle, glucose-alanine cycle, HMP shunt, hexose monophosphate shunt, and pentose phosphate pathway, PPE pathway, glycogen, urea cycle, nucleotides, fatty acid metabolism, ketone bodies, and structure of proteins. So let's start from amino acids. Amino acids NH2COH, alpha amino acids, and carboxylic acid NH2C double bond OH. Almost all naturally occurring proteins are alpha amino acids contain alpha amino acid, total 20 amino acids say 21st selenocysteine and 22nd pyrrolysine. Okay, 21st selenocysteine, 22nd pyrrolysine. Chiral asymmetric carbon. All amino acids have chiral carbon except glycine. All amino acids are optically active except glycine. R and D system. All amino acid yes configuration except cysteine like R. Configuration cysteine R configuration short like sister. D and L amino acids. All amino acids L configuration. Amino acids are CHNH2 COOH. Okay. Glycine NH2 CH2 C double bond OH. Next, alanine. These are the structure of alanine. CH3, single CH3, CH, NH2COH is the basic ring. CH3 methane, alanine. Short tricks from phenylalanine to tyrosine, serine, threonine, cysteine, methionine, tryptophan, histidine. So short tricks, phenylalanine, tyrosine. So for alanine, attach phenyl groups like phenyl benzene ring, CH2, CHNH2, COH. It's common like alanine, so phenylalanine. In phenylalanine, add OH groups like benzene ring contain phenol hydroxy heterocyclic nucleus. So that's a tyrosine. Okay, tyrosine, phenylalanine, hydroxy phenylalanine. Next, serine, same OH without benzene ring, contain alcoholic hydroxy group. Alcoholic hydroxy group. Serine, in threonine, attach CH3 groups, one CH3 groups, threonine. After that, cysteine, sulfhydryl group, sulfur, sulfhydryl mercaptothiol alcohol, NH2CH Okay, cysteine, methionine, thioether, sulfur, sulfide, and thioether attached in between. Same remaining structure is a alanine structure. After that, tryptophan indole plus trip पे तीन लोग गए indole plus third position erythrocyte sedimentation. Okay, electrophilic substitution reaction at third group. Indole, same alanine structure, CH2 CH NH2 COH. In indole, benzene plus pyrrolide. Okay, pyrrole rings, benzene plus pyrrole. So indole 1 2 3 third position, and alanine group attached. Histidine same, imidazole group attached here. Here indole group, indole in tryptophan and histidine imidazole. Imidazole means one third nitrogen. Aliphatic branch chain amino acids, valine, leucine, isoleucine. In valine, vanilla इस पर रखते हैं isopropyl, isopropyl alanine like that. Valine, leucine, अबूले आइसक्रीम खा ले isobutyl. In valine isopropyl, in leucine isobutyl. In leucine isobutyl. Isoleucine CH3 CH2 CH CH3. Same like that leucine. In leucine there is a isoleucine, branch chain amino acids, valine, leucine, isoleucine. Deficiency alpha keto acid dehydrogenase cause must like maple urine syrup disorder. Okay, branch chain amino acids, valine, leucine, isoleucine. Deficiency alpha keto acid dehydrogenase cause must maple urine syrup disorder. Basic amino acids, arginine, lysine, and histidine. Okay, arginine, lysine, histidine. Base NH2 or NH3. Positive charge cation polar. Arginine structure, अर्जित गाना ट्राई करता है, गाना गोनेडिन ट्राई थर्ड. So Try, okay. NH2 COH CH common. Try 3 methyl groups like CH2 3 times, and gonadine structure, arginine. Lysine, ambulaya like amino butyl. Lysine, amino butyl, NH2 CH2 4 CH same. Ambulaya, lysine. Next, acidic acids, aspartic acid and glutamic acids. Okay, aspartic acid and glutamic acid, negative charge anion. Aspartic acid, aspartate, NH2 CH C double bond OH and CH2 C double bond OH. Same, CH COOH, CH2 COH, NH2 one one NH2 group attached. Okay, and two hydrocarboxyl groups, so acidic. In glutamic acid, third. Okay, glutamate, aspartic acid, asparagine, glutamic acid, glutamine. So just attach amino group in asparagine, one more amino group contain amide bond. Okay, C double bond O NH2, these are the amine bond. Asparagine. In glutamine, same, C double bond O NH2, but here three carbons chain. Glutamate. Okay. In aspartic acid 2, glutamic acid 3. Proline alpha amino acids, NH2 alpha C double bond OH, heterocyclic nucleus pyrrolidine. Heterocyclic nucleus pyrrolidine. Acidic amino acids, aspartic acid and glutamic acids. Basic amino acids, arginine, lysine, histidine. Aromatic, phenylalanine, tyrosine and tryptophan. And polar charged basic amino acids and acidic amino acids. Polar uncharged amino acids, OH group containing serine, threonine and tyrosine. And sulfhydryl, cysteine and methionine. And carboxymide like amide group, asparagine and glutamine. Neutral amino acids, one amino group plus one carboxyl group. Basic amino acids, two amino group plus one carboxyl group. Acidic, one amino, two carboxyl. Arginine is the precursor of a nitric oxide. Okay, arginine is the precursor of a nitric oxide. NH2 RCH C double bond OH. These are the basic amino acid structure. Deuterion dipolar ion. Amino acid form positive charge, negative charge. Okay, positive, otherwise negative charge are called deuterion. All amino acid form deuterion at a particular pH. Acidic medium, hydrogen donate, cation plus cathode migrate. In a basic medium, hydrogen accept, anion, anode positive. Isoelectric point, the pH at which all amino acid has no charge or zero charge, no migration towards cathode or anode. At isoelectric point, amino acids least soluble. Okay. At isoelectric point, amino acids least soluble. Essential amino acids, total 9. Indispensable amino acids, also called, cannot synthesize in our body, taken through meat. Hi, there is Mawali, finally triple laya. So उसे short trick से Hi Arjit, there is Mawali, finally triple laya means histidine high is semi essential, and arginine also semi essential. Okay, there is Mawali, threonine, isoleucine, methionine, and valine. And finally, triple I, phenylalanine, tryptophan, leucine, and lysine. Ketogenic amino acids L2K, like leucine and lysine, both are ketogenic. Otherwise, all are like in a ketogenic. Are, see, ketogenic amino acids formation of a ketone bodies. Example leucine and lysine, L2K. Both ketogenic and glucogenic amino acids. Benzene is tha like benzene containing, and tha means threonine, is means isoleucine. Okay, leucine, lysine. Isoleucine is a both ketogenic and glucogenic. Benzene, phenylalanine, tyrosine, and tryptophan. Isoleucine, threonine. Glucogenic, all remaining amino acids. Next, amino acid as a precursors: tyrosine, melanin, dopamine, and thyroxine. Thyroxine, histidine, histamine, lysine, carnitine, glutamine, GABA, arginine, nitric acid. Let's see. tyrosine, melanin, dopamine, thyroxine, histidine, histamine, lysine, carnitine, glutamine, GABA, arginine, nitric acid. Non-protein amino acids and their functions. See, ornithine, intermediate in biosynthesis of a urea. Citrulline, intermediate in a biosynthesis of a urea, same ornithine and citrulline. Thyroxine, thyroid hormone. Yes, adenosine methionine, methyl donor in a biological system. 3,4-dihydroxyphenylalanine, like DOPA. 3,4-dihydroxyphenylalanine, DOPA. Neurotransmitters precursor for a dopamine, melamine. Gamma aminobutyric acid, GABA. Neurotransmitters product from a glutamic acids. Beta amino isobutyric acid, end product of a pyrimidine synthesis. Okay, beta aminobutyric acid. Gamma aminoleucinic acid, intermediate in a synthesis of a porphyrin heme. Gamma aminoleucinic acids. N-acetylcysteine used in a cystic fibrosis. N-acetylcysteine used in a cystic fibrosis. Amino acids soluble in water, insoluble in organic solvents. Melting point above 200 degrees Celsius. Taste sweet, glycine, alanine, valine. Tasteless, leucine. Bitter, arginine, isoleucine. All amino acids optically active except glycine, as ampholyte contain both carboxyl and NH2 group, can donate a proton or accept a proton, ampholyte. Natural amino acids containing compounds: methionine, enkephalin, 5 amino acids; angiotensin 2, 8 amino acids, octapeptide; angiotensin 2, octapeptide, 8 amino acids; vasopressin, oxytocin, and bradykinin, 9 amino acids, nonapeptide; vasopressin, oxytocin, and bradykinin. Next, calidin and angiotensin first, 10 amino acids, decapeptide, and angiotensin second, 8 peptides; gastrin, 17 amino acids; glucagon, 29; insulin, 51 amino acids. All are polypeptides. Okay, let's see once again. Gastrin, 17; glucagon, 29; insulin, 51; calidin and angiotensin 2, 10; vasopressin, oxytocin, and bradykinin, 9; angiotensin 2, 8 amino acids; methionine, enkephalin, 5 amino acids. Metabolism of amino acids, like convert from urea cycle: formation of a carbamyl phosphate, formation of a citrulline, formation of a arginosuccinate, cleavage of arginosuccinate. Arginine is a precursor, fumarate is a byproduct. 4 ATP consumed. Carbamyl phosphate synthetase, rate limiting step. Carbamyl phosphate synthetase, rate limiting step. Disorders of metabolism of amino acids or defects or deficiency: alkaptonuria, homogentisate oxidase; alkaptonuria, homogentisate oxidase; phenylketonuria, phenylalanine hydroxylase; maple syrup urinase, alpha keto acid dehydrogenase, mainly branch chain amino acids deficiency; tyrosinemia, fumaryl acetoacetate hydrolase; tyrosinemia, fumaryl acetoacetate hydrolase; homocystinuria, cystathionine beta synthase; Hartnup disease, defects in intestinal absorption of tryptophan; Hartnup, tryptophan; albinism, tyrosinase. Remember, albinism, tyrosinase; Hartnup, tryptophan; albinism, tyrosinase; homocystinuria, cystathionine beta synthase; tyrosinemia, fumaryl acetoacetate hydrolase; maple syrup, alpha keto acid dehydrogenase; phenylketonuria, phenylalanine hydroxylase, pH; and alkaptonuria, homogentisate oxidase, alkaptonuria. Next, metabolites of amino acids, mainly transamination, transfer of amino group from an amino acid to keto acid, catalyzed by the enzyme transaminase aminotransferase. Transaminase requires a coenzyme, pyridoxal phosphate. Transaminase require a coenzyme, pyridoxal phosphate. Test for amino acids. Biuret test histidine. Pauli test histidine. Biuret and Pauli for histidine. Okay. Hopkins call tryptophan. Millen's test tyrosine. And xanthoprotic test tyrosine. Mainly for xanthoprotic test aromatic amino acids. Let's see. Biuret histidine. Pauli histidine. Hopkins tryptophan. Millen's test and xanthoprotic test tyrosine. Symbol for amino acids: alanine A, arginine R, asparagine N, aspartic acid D, cysteine C, glutamic acid E, glutamine Q, tryptophan W, and lysine K. Okay, these are the important like alanine A, arginine R, aspartic acid N, asparagine. Okay, asparagine, not aspartic acid. Asparagine N, aspartic acid D, cysteine C, glutamic acid E, glutamine Q, lysine K, tryptophan W. Next, some remembers: glycine G, histidine H, isoleucine I, leucine L, methionine M, phenylalanine F, proline P, serine S, threonine T, tyrosine Y, and valine V. So mainly these importance: arginine, alanine, glutamic acid E, glutamine Q, lysine K, tryptophan W. So these are the vitamins. Next, lipids: ghee, butter, oils. Lipids chemically are acids like fatty acids. High molecular weight formula: CH3 one end and COH another end, in which CH2 many. Fatty acids plus alcohols: high molecular weight fatty acids plus alcohols called fatty esters. Total carbons n plus 2. Okay, total carbons n plus 2. Simple lipids, fatty acids, fatty esters. Lipids: simple lipids, complex lipids, fatty acid esters, plus protein, lipoproteins, plus carbohydrate, glycolipids, plus phosphate, phospholipids. And derived lipids, they are neither fatty acids esters. They mimic the property of a lipids like cholesterol. Simple lipids: fatty acid plus glycerol, glyceride esters, room temperature oil, room temperature solid, fats vasa. Okay. And fatty acid plus any alcohol, wax, except glycerol. Okay. Fatty acid plus any alcohol, wax, except glycerol. Next, diglycerol, triglyceride, monoglyceride. Okay. Fatty acid ester 1, 2, and 3. Short chain triglyceride, more ester value. Long chain triglyceride, less ester value. Opposite. Evaluation of lipids: iodine value to determine extent of unsaturation in lipid sample. Number of grams of iodine absorbed by 100 grams of a fat sample. Iodine value lowest 7 to 10 grams. Coconut oil unsaturation low. Okay. Iodine value highest 175 to 200 gram. Example, linseed oil. Increase unsaturation, oxidation, rancidification. Okay. So mainly iodine value for unsaturation and rancidification. Next, Christ test, rancidity detection, determines extent of oxygen free radicals, peroxide radical. Christ test, peroxide radical. Next, in Christ test, fluoroglycerol plus hydrochloric acid, pink or red color. Saponification value, milligram of KOH to saponify 1 gram of a fat sample are called saponification value. And another in KOH plus fatty acid, soap, salt, aqueous KOH, hydrolysis, fatty ester plus fatty acid, neutralize, lipid soluble, hydrolysis plus neutralize, saponification. Saponification value, ester value plus acid value. In ester value, uh, number of milligram of a KOH to hydrolysis to fatty acids in a 1 gram of fat. Ester value for hydrolysis, esters, and acid value to neutralize free fatty acids in 1 gram of fat sample. Okay, acid neutralize. Next, saponification value advancement Richard's missile value, advancement Polinsky value, like requires 75 grams of fat sample complementary polar insoluble Polinsky, and fat sample little bit polar soluble fat. Saturated fatty acids, total number of carbons. Saturated fatty acids, okay, there is no double bond, like मेरे लॉरिक LMPS एबल, जो बच्चे लैम्प्स में पढ़ते हैं, लैम्प्स में पढ़ने वाले बच्चे एबल बनते हैं, लाइक लैम्प्स मीन्स LMPS एंड एबल, like from 12 starting. Lauric acid 12, myristic acid 14, palmitic acid 16, stearic acid 18, arachidonic acid 20, behenic acid 22, and lignoceric acid 24. Okay. So lauriac, myristic, palmitic, stearic, and arachidic acids, okay, are called saturated, means no double bonds. And next, in delta mononomenclature, there is 16, like a double bond. Stearic acid, total number of carbon stearic acids 18, okay. Number of double bond, first double bond 9 position, these are the unsaturated, okay. Stearic, LMPS, if there is a normal structure of a stearic acid, just guys listen, a total number of carbon 18, if there is a 3 double bonds in first 9th position, 12th position, and 15th position, if there is a omega 9 in first position, oleic acid, second linoleic acid, and then linolenic acids, like 9 9 12 and 9 12 15, omega 3 50 acids, okay, total 13. Stearic acids, LMPS 18 stearic acids, also called vitamin F, okay. Linoleic, essential fatty acids, linoleic acids, and linolenic acids. Oleic acids, linolenic acids, all are containing 18 carbons. Oleic, linoleic, and linolenic. Essential fatty acids, vitamin F, okay. Omega nomenclature, from last to delete. Omega 9, delta 9, 9 12, and omega 3 15. Omega 3 most. Next, same for 16 palmitic acid, 16 1 palmitolic acids. Next, 24, 20 and 4 arachidonic acids. 20 means number of carbon bonds, carbons, and 4 means number of double bonds, okay. Vanaspati की complete saturation 5 8 11 12. So next topic, carbohydrates. So carbohydrates, hydrates of carbon, polyhydroxyaldehyde or ketone, or compound which on hydrolysis gives polyhydroxyaldehyde or ketone, aldose CHO, and ketones C double bond O, okay. On the basis of number of carbon atoms, triodes, CHO CH2OH, diglyceraldehyde, chiral carbon 1, chiral carbons means different groups are attached on it. Chiral carbon over glycerol ketoxy, like CH2 CH CH2OH. Triodes is aldehyde, diglyceraldehyde, chiral carbon 1, and stereoisomer 2 raised to n means 1 2. Relative configuration D and L, chiral carbon of if OH right side then D, and OH its left side then in L. These are the L glyceraldehyde, 3 carbon atoms, L glyceraldehyde. Next, increased carbon ascending triose, tetrose, pentose, hexoseptose are called Fischer-Killiani synthesis. Second carbon is always a epimeric carbon, okay. And last, all chiral all chiral carbons means epimeric carbons, मतलब all chiral carbons except D and L carbon, जो कि शो करता है कि D कंपाउंड है और L कंपाउंड है, ओके. These are the erythros, 4 carbon atoms, erythros, chiral carbon 2, ओके. सो स्टेरियोआइसोमर 2 raised to 2 4. सो उसमें क्या बनेगा, एक ही इपीमेरिक कार्बन है. सो एरिथ्रोस का क्या है इपीमर, 3 If more chiral carbon present, then for D and L, consider long distance chiral carbon from functional group, okay. So D erythros and D threos are epimers of each others. Erythros and threos are C2 epimer of each other. Enantiomers, mirror image but not superimpose. Okay, mirror image but not superimpose. Glyceraldehyde and DL-glyceraldehyde are enantiomers. Next, diastereomers, neither mirror image nor superimpose greater than 2 chiral carbons. Erythros, 2 chiral carbons. Okay. C2 epimer, D3Os. Epimers are a diastereomeric pair. Next, 5 ribose, 3 chiral carbon, 2 raised 3 means 8 epimers C2 and C3. C2 epimers D arabinose and D xylose. Okay, all hydroxyl groups always a right side, but in glucose condition there is a third one is a difference. Okay, irribose epimer C2 epimer arabinose and C3 epimer xylose. Next, in glucose, third hydroxy groups are attached. D glucose, there is a 3 epimers of a glucose. MAG like mannose, allose, and galactose. C2 epimer, C3 epimer, and C4. D mannose, D allose, and D galactose. Okay. C3 epimers. C2, C3, and C4. Glucose chiral carbon 4, 2 raised to 4 stereoisomers, 2 raised to 4 16. D mannose, D allose, and D galactose are the 3 epimers of glucose. Mannose, allose, and galactose. Glucose fructose. Anomer cyclic form, ring made between functional group and longest chiral carbon atom. Hemiacetal 1 hydroxyl, 1 aldehyde, and 1 hydroxy. Acetal 1 hydroxyl, 1 aldehyde, and 2 hydroxy. Acetal. Same like ketal. Hemiketal means 1 1 and ketal means 1 2. Next, anomers like these are the normal D glucose in middle structure D glucose and form structure of alpha D glucose. Anomeric carbon, first one is a anomeric carbon. Okay, bond between O, hemiacetal alpha 112 degree, specific rotation by using polarimeter, and beta D glucose. Okay, if OH is a right side, then it's a alpha. Let's say anomeric carbon alpha OH right side and beta OH left side. In D and L, if OH it's a right side, then it's a D and L is for left side. Okay. Alpha D glucose and beta D glucose are anomers of each other. Means only changing on one carbon group. Anomers are a diastereomeric pair. Mutarotation, it means change a specific rotation of a compound. Cyclic compound shows butarotation. Anomeric carbon shows mutarotation. Alpha beta glucose shows mutarotation. Next, these are the Howard formula. Glycopyranose, right side downward. Pyrone. Fructose, alpha D fructose, fructofuranose. Next, important oxazone formation. Phenyl hydrazine. Okay. Oxazone formation, phenyl hydrazine. 3 moles of a phenyl hydrazine are called Amadori mechanism. Amadori mechanism. Oxazone form always at first and second position, uses third moles of a phenyl hydrazine for maintenance. Like first glucose, okay, NH2 NH2 combine oxazone glucose phenyl hydrazine first mole. Next second mole for oxidation oxidize करता है adjust carbon atom को and third phenyl hydrazine. So third mole for oxidation, okay, are called glucosazone, oxazone formation. Let's see, glucose, fructose, and mannose, same oxazone, needle shape, yellow color. Glucose, fructose, and mannose, glucose, fructose, and mannose, same oxazone, needle shape, yellow color. Galactose, thorn shape, broad shape. Aldehyde to ketone, free oxazone formation. Aldehyde to ketone, free oxazone formation. Reducing sugar. Sugar reduces Fehling solution, Tollin solution, and Benedict solution. Reducing sugar, if not reduces, non-reducing sugar. Sugar reduces Fehling, Tollwins, and Benedicts. These 3 reagents, Fehling, Tollens, and Benedicts. Reducing sugar, free aldehyde and ketone, hemiacetal, and non-reducing sugar, only acetyl form. All monosaccharides, glucose, fructose, galactose, and ribose, are a reducing sugar, and in disaccharide, maltose, isomaltose, lactose, and lactulose. In acetal form, in non-reducing, disaccharide only one, sucrose, trisaccharides, trehalose, raffinose, all polysaccharides, starch, cellulose, and inulin are non-reducing. In disaccharides, first one is a maltose. Glucose, glucose are called maltose. Maltose. Alpha D glucose, alpha D glucose. Okay. Alpha 1 for glycosidic linkage. Free aldehyde group, reducing sugar, oxidation formation, and muta rotation. Okay. Let's see. Maltose, alpha D glucose and alpha D glucose maltose. Next, lactose or beta D galactose and beta D glucose. In maltose, there is alpha D glucose, alpha 1 4. In lactose, beta D galactose and beta D glucose. बीटा 1 4 ग्लाइकोसिडिक लिंकेज. गली से गुल्लू जा रहा है दूध लाने. ओके. गली गैलेक्टोस गुल्लू ग्लूकोस क्या करने जा रहा है दूध लैक्टोस. लैक्टोस इज अ मिल्क शुगर. बीटा डी गैलेक्टोस एंड बीटा डी ग्लूकोस बीटा 1 4. Free hydroxyl free aldehyde group, reducing sugar, oxazome formation, puff powder, muta rotation formation. Sucrose, inward sugar, cane sugar. Alpha D glucose plus beta D fructose. Alpha beta 1 2 glycosidic bond. In sucrose, glucose plus fructose, alpha 1 2 glycosidic linkage. ऑल द बेस्ट बोला गर्लफ्रेंड को, उसने शुक्रिया बोला. अल्फा बीटा ग्लूकोज फ्रुक्टोज, शुक्रिया सुक्रोज. ओके. नो फ्री फंक्शनल ग्रुप, नॉन रिड्यूसिंग शुगर, नो ऑक्सीजन फॉर्मेशन, नो म्यूटा रोटेशन. All polysaccharides are non-reducing sugar. In starch, alpha D glucose, alpha 1 4. Okay. In maltose also alpha D glucose. Amylose, amylopectin. Amylose soluble, linear. Amylopectin insoluble branch. Amylose soluble, linear. Amylopectin insoluble branch. Next, cellulose, beta D glucose, beta 1 4. Inulin, beta D fructose, beta 2 1, glycosidic. Glycogen, storage form of a glucose, alpha D glucose, alpha 1 4, alpha 1 6 linkage. Okay, glycogen. In cellulose, beta D glucose only, beta 1 4. Inulin, beta D fructose, beta 2 1. Okay, these are the cellulose, beta D glucose, inulin, glycogen. Cellulose, beta D glucose, inulin, beta D fructose, glycogen, alpha D glucose, alpha 1 4, alpha 1 6. Next, enzymes. Thermolabile, specific, and colloidal solution. Okay, proteinase compound. Enzymes, proteinase like ligase, isomerase, lyase, hydrolase, oxidoreductase, and transferase. ओके. एंजाइम कमीशन, इसी मीन्स एंजाइम कमीशन. लाइगेज, लाइगेशन ज्वाइनिंग का काम करवाते हैं लाइक डीएनए लाइगेज. आइसोमरेज, दोज एंजाइम कन्वर्ट्स वन आइसोमर इनटू अनदर लाइक ग्लूकोज टू फ्रुक्टोज. ओके. लाइज ब्रेक लाइसिस विदाउट वाटर. एंड हाइड्रोलेज लाइसिस विथ वाटर हाइड्रोलिसिस. esterase lipase, amidase peptidase, amylase diesterase. Okay. Amylase diesterase break glycosidic bond, amylase diesterase. Hydrolase lysis with water hydrolysis. Esterase lipase, amidase peptidase, amylase diesterase break glycosidic bond. Oxidoreductase reaction, redox reaction. Oxidase, peroxidase, reductase, dehydrogenase, OR dehydrogenase, reversible and 2 hydrogen remove oxidation, 2 hydrogen gain reduction. Helpers NAD and FAD like coenzyme. Okay. NAD fat. Next, transferase, aminotransferase, transaminase, methyltransferase, transmethylase, and phosphate transferase kinase. These are the important. Phosphate transferase kinase. Structure of enzymes: inactivated precursor of enzymes, zymogens. Okay. After converted into activated enzymes, zymogens, remember, inactivated precursor of enzymes. Enzyme structure: proteinase part major portion, non-proteinase part minor portion. In proteinase part major portion, apoenzyme. Okay. In a proteinous part, non-proteinous part, organic coenzyme and non-organic inorganic cofactor. सो होलो एंजाइम एपो एंजाइम प्लस को एंजाइम कोफैक्टर को क्या बोलते हैं हम? होलो एंजाइम. ओके. फंक्शनल यूनिट ऑफ एंजाइम होलो एंजाइम. प्रोस्थेटिक ग्रुप एपो एंजाइम कोवेलेंटली बाइंड with non-proteinous part permanently bound. Next, proteinous part specificity of enzyme substrate enzyme induced field theory coastlands. Factors affecting enzyme activity: pH and temperature, bell shape curve, velocity, pH, temperature, optimum pH, temperature, good action. A majority of enzymes prefer room temperature for their action. There are few enzymes which prefer very high temperature for their action, like thermus aquaticus, thermomaritema, thermus pluricoccus, thermolitoxylus. Okay, all are the DNA polymerase enzymes are stable at a 70 to 100 degrees Celsius and 60 degrees Celsius ureates. Enzyme concentration, enzyme velocity, enzyme concentration, straight like curve, directly proportionality. Okay. Next, substrate concentration, enzyme velocity, rectangular hyperbola graph. After Vmax, there is a substrate normal, unstable concentration. Okay. No free enzyme, enzyme substrate complex mix, unstable complex. Velocity, velocity and substrate. Vmax, maximum velocity, half Vmax means substrate. Km value, less substrate. More affinity of enzyme towards substrate. More affinity of enzyme towards substrate. Less value, less substrate. Okay, Km value. Concentration of substrate required to achieve half Vmax of an enzyme. Those substrate concentrations are called Km value, mutually maintained constants. Enzyme having low Km value for substrate indicates higher affinity towards substrates. Okay, and vice versa. A low Km value means higher substrate, and vice versa. Next, concept of activation energy, stable activation energy product, enzyme substrate unstable complex, activation energy less energy, product plus enzyme. The enzyme work by lowering the overall activation energy of an reaction. This is achieved by formation of the unstable enzyme substrate complex. And next important, enzyme inhibition, reversible and irreversible. Irreversible means permanently inhibition, like acetylcholinesterase, example diphos, nerve gases. In reversible, competitive, non-competitive. Okay. In a competitive, Km value increase, Vmax constant, and in a non-competitive, Vmax decrease and Km constant. Okay. How to remember? Competitive, Km value increase. Competitive enzyme inhibitor, first Km less, then Km second, and Vmax constant. Okay, are the competitive. Remember, Km1 is less than Km2. Okay, Km increase, Vmax constant. Km increase, Vmax constant. Substrate inhibitor competition, Km value. In competitive inhibitor, Km value increase, whereas Vmax remains constant. Xanthine oxidase, allopurinol drug, alloxanthine, xanthine uric acid gout, both are the acting on the same enzyme. Non-competitive inhibitor, enzyme inhibition, Vmax lowered, Km constant. Vmax lowered, Km constant, allosteric site, enzyme substrate, Vmax lowered, Km value constants. Enzyme non-proteinous, inorganic cofactor, and organic coenzyme. Okay. Inorganic cofactor, organic coenzyme. So first see cofactor, inorganic. FeCO cytochrome oxidase C450, fail peroxidase and catalase. फेल फेल होने के बाद घर वालों ने पर काट लिए मीन्स फेल मीन्स फेरस एल्यूमिनियम. ओके, peroxidase and catalase, FeCO cytochrome oxidase C450. Next, molybdenum xanthine oxidase dihydrogenase, मौली ने जान दी, molybdenum मौली xanthine oxidase dihydrogenase. जिंक कार, जंग लगी कार को अल्कोहल से साफ किया मीन्स जिंक कार, कार्बोनिक अनहाइड्रेस, कार्बोक्सिलेस, अल्कोहल डिहाइड्रोजनेस. ओके. निकेल यूरिएट्स, calcium amylase. Calcium amylase. Application of enzymes. Disease treatment like anti-inflammatory enzyme, papain, bromelains, succinylins, trypsin, and chymotrypsin. Anticoagulant, streptokinase, ureakinase, tapeplase enzyme, alteplase, retaplase. Tissue plasminogen activator. Anti-cancer, L-asparginase. Anti-cancer L-asparginase. Enzyme used as a diagnostic agent markers heart disease DH1, CPK2, SGOT, CT, cardiac troponin. CT means cardiac troponin, most prominent marker. Early marker of a heart disease CPK2. In hepatic SGPT, serum glutamyl pyruvate transaminase. Pyruvate, PR, love, hydroxy group, liver. Okay, लीवर खराब होगा हेपेटिक हेपेटोलेंटिकुलर डीजेनरेशन कपर सेल डिस्ट्रॉय कॉपर सेरुलोप्लाज्मिन ओके हेपेटोलेंटिकुलर डीजेनरेशन कपर सेल डिस्ट्रॉय कॉपर सेरुलोप्लाज्मिन increase acid phosphatase proceed like prostate cancer and increase alkaline phosphatase bone disease bolka gate pyq biological catalyst protein dna catalytic efficiency of enzyme kcat or km next some NAD lactate dehydrogenase selenium glutathione peroxidase pyridoxal phosphate glycogen phosphorylase molybdenum dinitrogenase okay enzyme antibodies that have catalytic activities protease enzyme proteasome trypsin and chymotrypsin ionophore gramicidin A aubacine sodium potassium ATPase malonate competitive inhibitor of a succinic dehydrogenase malonate competitive inhibitor of a succinic dehydrogenase alkaptonuria homogeneous acid oxidase protein hydrolyzing enzyme cathepsin protein hydrolyzing enzyme cathepsin kinase transfer phosphate group to biomolecules lyase cleave bonds by elimination synthase make large molecules from small molecules phosphatase remove phosphate group from biomolecules phosphatase enzymes metabolic pathway succinyl CoA synthetase TCA cycle acyl CoA dehydrogenase oxidation transcutulase PPP and ribulose 1,5 biphosphate carboxylase Kelvin cycle. Remember again enzyme and cycle succinyl CoA synthetase TCA cycle acyl CoA dehydrogenase oxidation transcutulase PPP ribulose 1,5 phosphate Kelvin cycle cofactor and function thiamine pyrophosphates aldehyde transfer coenzyme A acyl CoA transfer pyridoxal phosphate group transport to form amino acids tetrahydrofolate transfer of one carbon atom tetrahydrofolate transfer of one carbon atom coenzyme A acyl group transfer isocitrate lyase synthesis of glucose from acetate phosphoenol pyruvate carboxylic kinase conversion of amino acids into glucose pyruvate dehydrogenase complex lipoic acid phosphofructokinase all allosteric enzyme and pyruvate carboxylase biotin pyruvate carboxylase biotin km affecting of enzyme to the substrate kcat km catalytic efficiency of enzyme pka maximum buffering capacity ki affinity of enzyme to the inhibitor phosphofructokinase allosteric interaction glycogen synthase covalent modification lactate dehydrogenase product inhibition beta galactosidase control of enzyme synthesis vitamin B1 thiamine pyrophosphate carboxypeptidase zinc TCA cycle aconitase reducing sugar lactose okay reducing sugar lactose enzyme cofactor pyruvate decarboxylase thiamine pyrophosphate glyceraldehyde 3 phosphate dehydrogenase NAD pyruvate carboxylase biocytine glucose 6 phosphate dehydrogenase NADP. So now we see some cycles or pathways. So let's start from basics. Aldehyde to ketone conversion isomer to each other. Okay, aldehyde and ketone are isomer of each other. Isomerase enzyme is used. Glucose isomerase fructose. Functional group oxidation, primary alcohol oxidation give aldehyde, again oxidation give acid. Dehydrogenase enzyme. Oxidation dehydrogenase. NAD to NADH plus H plus ion 3 ATP. In new books 2.5 ATP. Single bond to double bond succinate dehydrogenase. Single bond to double bond dehydrogenase. And FAD to FADH to 2 ATP. Glucose to glucose 6 phosphate kinase. ATP directly involved in reaction. Outer involved नहीं होता. Consumer release phosphate. 3 phosphate glycerate to 2 phosphoglycerate mutase. 3 phosphoglycerate to 2 phosphoglycerate mutase enzymes. After that जब भी outer involve हो तो एज लगाना. outer एज glucose 6 phosphate to glucose 6 phosphatase. Glucose 6 phosphate to glucose 6 phosphatase. Substrate level phosphorylation SLP. ATP release, GTP release, ADP to ATP and GDP to GTP. Substrate formulation phosphorylation, ADP to ATP substrate. Glycolysis, breakdown of a glucose embedded in Markov pathway. Glucose aerobic and anaerobic. In aerobic pyruvate, in anaerobic lactate. Oxygen absent in erythrocytes. Oxygen absent in erythrocytes. Starting material precursor of a glycolysis is glucose. 10 enzyme 10 step. Pyruvate 3 carbon and lactate 3 carbon. Pyruvate aerobic, lactate anaerobic. Glucose 1, 3 and 10. These 3 enzymes are uh, irreversible. Okay. 1, 3 and 10 are irreversible. 3 enzymes are irreversible. Enzyme first, glucose or hexokinase. Enzyme third, phosphofructokinase or PFK. And last, pyruvate kinase. Let's see. 3 enzymes are irreversible. All 3 are kinase. Third are rate limiting enzymes in glycolysis is phosphofructokinase first. Are a rate limiting enzyme. Conversion of pyruvate to acetyl CoA in mitochondria. Conversion of pyruvate to acetyl CoA in mitochondria. Glucose to glucose 6 phosphate, glucokinase in liver and hexokinase in tissue. Okay, glucokinase in liver and hexokinase in tissue. Hexoisomerase, glucose 6 phosphate to fructose 6 phosphate, hexoisomerase. After that, fructose 6 phosphate to fructose 1 6 biphosphate, phosphofructokinase. After that, triose isomerase, glycerylate 3 phosphate to 1 3 bis phosphoglycerate enzyme dehydrogenase. 3 phosphoglycerate dehydrogenase. Again 3 phosphoglycerate kinase. Okay. 1 3 biphosphoglycerate to 3 phosphoglycerate kinase. After that, 3 phosphoglycerate to 2 phosphoglycerate mutase. After that, 2 phosphoglycerate to 2 phosphoenol pyruvate enolase. And last enzyme is a 2 phosphoenol pyruvate to pyruvate kinase. Enolase inhibited by fluoride. Tautomerism, delocation of a hydrogen from one position to other. Okay, ketopyruvate to enol pyruvate, just removal of oxygen. 2 enzyme substrate level like 7 and 10, phosphoglycerate kinase and pyruvate kinase. Deficiency of pyruvate kinase, hemolytic anemia. G6PD, glucose 6 phosphate dehydrogenase. Aerobic condition 8 ATP consume. 3 phosphoglyceraldehyde dehydration. NAD to NADH 2 times, so 6 ATP. Phosphoglycerate kinase 1 ATP 2 ATP. Pyruvate 10 release. 10 release 2 consume, so net ATP 8 ATP. Okay, in aerobic condition 8 ATP and in anaerobic 2 ATP. Aerobic 8 and anaerobic 2. Next, Rappaport-Leuporing, RL shunt, RBCs erythrocytes, 1 3 bis phosphoglycerate to 2 3 bis phosphoglycerate mutase. Okay, same 3 ATP, pyruvate dehydrogenase. Next, TCA cycle, also called tricarboxylic acid cycle or Krebs cycle or citric acid cycle, CAC. Citric acid 3 carbons, isocitrate, acetate, acetyl CoA, oxalate, oxalo, oxaloacetate, succinate, malate, and malate. Okay, succinate, malate, and fumarate, trans isomer, malate cis isomer, and fumarate trans isomer. These are the oxalosuccinate, succinyl CoA, glutarate, alpha ketoglutarate, succinate to fumarate, succinate dehydrogenase. Okay, double bond attached only. In succinate, only double bond attached. Succinate to fumarate, succinate dehydrogenase. Hydrogenase double bond attached. Malate to oxaloacetate. TCA cycle occurs in mitochondria, only aerobic cycle. Okay. Final metabolic pathway of carbohydrate, fats, lipids, amino acids. TCA cycle only aerobic cycle occurs in mitochondria. Next, also called as amphibolic cycle, catabolism, energy release large to small, and anabolism small to large, energy consumed. Amphibolic, both catabolism and anabolism. All enzymes are present in a mitochondrial except succinate dehydrogenase, inner intramitochondria. All enzymes are oxidative phosphorylation except succinyl CoA synthetase or succinyl thiokinase, substrate level phosphorylation. Alpha ketoglutarate, number of carbon dioxide loses in TCA cycle is a 2. Two outer molecule completely consumed, aconitase and fumarase. Two outer molecule completely consumed, aconitase and fumarase, only aerobic cycle. TCA irreversible enzyme 134. Citrate synthase isocitrate dehydrogenase, alpha ketoglutarate dehydrogenase, starting material oxaloacetate. And rate limiting enzyme क्या है? Isocitrate dehydrogenase. So these are the tricks. Oxaloacetate starting material. After that citrate, isocitrate, alpha ketoglutarate, succinyl CoA, succinate, fumarate, malate, and oxaloacetate. Okay. These are the reaction. Oxaloacetate, acetyl CoA, citrate synthase, citrate 6 carbon, aconitase, outer molecule, isocitrate, oxalosuccinate, isocitrate dehydrogenase, alpha ketoglutarate dehydrogenase, alpha ketoglutarate dehydrogenase, alpha ketoglutarate dehydrogenase, then succinyl CoA. After that, succinyl thiokinase, succinate. After that, succinate dehydrogenase, it's fumarate. After that, fumarate to fumarate, malate, and malate dehydrogenase, oxaloacetate. Oxaloacetate. Okay. 1 TCA cycle, 12 ATP release. 1 TCA cycle, 12 ATP release. Aconitase inhibited by fluoroacetate, suicide inhibitor. Arsenite inhibit alpha ketoglutarate. Malonate inhibit succinate dehydrogenase. 1 mole glucose glycolysis plus TCA pyruvate. Anaerobic condition 2 ATP and aerobic condition 8 ATP glycolysis. TCA cycle 24 ATP, pyruvate 6 to total 38 ATP. Gluconeogenesis, synthesis of glucose from non-carbohydrate source like 3 carbons, propionate, pyruvate, lactate, glycerol, and glycogenic amino acids like alanine. Gluconeogenesis, mitochondrial enzyme, pyruvate carboxylase, cytosol mostly here, and cytoplasmic reticulum, glucose 6 phosphate. Okay. Rate limiting enzyme, pyruvate carboxylase, phosphoenol pyruvate kinase, fructose 1,6 bisphosphate like glucose to glucose 6 phosphate, glucokinase, hexokinase. Okay, and glucose 6 phosphate is okay again converts into glucose. Fructose to 6 phosphate, fructose 1,6 biphosphate. Okay, these are the glycerol to glycerol 3 phosphate, again dihydroxyacetone 3 phosphate, glycerol kinase. After that, Cori cycle, glucose, glucose 6 phosphate, pyruvate, lactate in muscle and liver, blood. Again, lactate convert to pyruvate, pyruvate to glucose 6 phosphate, glucose 6 phosphate to glucose. Glucose alanine cycle or Cahill cycle, muscle and liver, glucose, glucose 6 phosphate, pyruvate and alanine, transaminase. Okay, ऊपर lactate था, कोरी साइकिल में लैक्टेट था, और एलेनिन साइकिल में एलेनिन है ट्रांसअमाइनेस, एलेनिन टू पायरुवेट ट्रांसअमाइनेस, ट्रांसअमाइनेस रिवर्सिबल एंजाइम कीटोन टू अमाइन, ट्रांसफर ऑफ अमाइनो ग्रुप, पायरुवेट टू एलेनिन ट्रांसअमाइन ग्रुप. Okay. Next, 2 ATP pyruvate to glucose, 2 ATP lactate to glucose, 2 ATP alanine to glucose, 2 ATP. So total 6 ATP consumed. HMP short hexo monophosphate pathway, pentose phosphate pathway, or Dickens Lipman pathway. Okay. HMP short triple P pentose phosphate or Dickens Lipman. Alternative cycle for glucose oxidation. It is multicyclic process. Formation of a NADPH, 2 moles of NADPH propate, 1 carbon dioxide release, 1 ribulose 5-phosphate, synthesis of purine, pyrimidine, DNA, RNA, synthesis of pentose sugar, formation of fatty acids, cholesterol. All enzymes are present in a cytosol. Transketolase 2 carbon unit transfer from ketone, and transaltolase 3 carbon unit transfer from ketone. Oxidative irreversible, non-oxidative non-reversible. Starting material ग्लूकोज 6-phosphate, देन राइबोलोस 5-phosphate, उसका कन्वर्जन होगा फ्रुक्टोज 6-phosphate और ग्लिसरॉल्डाइड 3-phosphate में. नो ATP यूज इन एच एम पी शांट. ग्लूकोज 6-phosphate, ग्लूकोज फॉस्फोग्लूकोनेट, राइबोलोस 5-phosphate, hemolytic anemia deficiency, glucose 6-phosphate dehydrogenase. Okay. Non-oxidative ribulose, these are the not important. So next, glycogen, store form of a glucose in liver, alpha 1,4,1,6 glucosylunate. Glycogenesis, formation of glycogen from glucose. Glycogenolysis, breakdown of glycogen to glucose. Glycogen alpha 1,4,1,6 glycosyl, branching enzyme. Okay. Glycogen phosphorylase, rate limiting enzyme, glucose transferase, debranching. Glucose 1 phosphate, glucose 6 phosphate, again glucose. And last one is a glycogen storage disease. Type 4 glycogen synthase, Lewis disease. Type 0 Lewis disease, glycogen synthase. Type 1 Van Gogh syndrome, glucose 6 phosphatase. Van Gogh syndrome, glucose 6 phosphatase. Pompe's disease, lysosomal alpha 1,4 glucosidase, acid maltase, Pompe. Cori disease or debranching enzyme, amylo alpha 1,6 glucosidase, Cori disease. Anderson disease, deficiency of branching enzyme like amylopectinosis. Anderson disease, amylo alpha 1,4,1,6 transglucolase. McAlde muscle glycogen phosphorylase. Her disease, liver glycogen phosphorylase. And Taru disease, deficiency of a phosphofructokinase muscle phosphofructokinase. Okay. Anderson debranching amylopectinosis. Cori debranching amylo alpha 1,6. Pompe lysosomal acid maltase, Pompe lysosomal. Van Gogh glucose 6 phosphatase. And type 0 Lewis disease, glycogen synthase. So next cycle is urea cycle, also called ornithine cycle. Scientist Krebs Hensley cycle. First metabolic cycle, ammonia convert into urea. Protein or amino acid, nitrogen, ammonia convert into urea in liver. Okay. Metabolism occurred in liver, then kidney excretion. Where is urea excretion? Urea synthesis occurred in liver and excretion by kidney. Synthesis occurs in liver. Enzyme of urea cycle present in mitochondria and cytosol. Total 5 enzymes. First and second in mitochondria, and first like CPS, carbamyl phosphate synthetase. First are a rate limiting enzyme, and second is a OTC, ornithine trans carbamylase. OTC, ornithine trans carbamylase. All steps are irreversible. Total 4 ATP consumed in urea cycle. So there is a fumarate is the link between urea cycle and TCA cycle. Fumarate is the link between urea cycle and TCA cycle. These are the structure of normal NH2, NH2, C double bond O. Okay, ammonia. First nitrogen from ammonia, second carbon from carbon dioxide, and third from aspartate. Carbamate NH2 C double bond O, carbamoyl NH2 C double bond O, acetate, and these are the structure ammonia plus carbon dioxide in the presence of carbamoyl phosphate synthetase converted into carbamoyl phosphate, and then mainly reaction starting from citrulline, arginosuccinate, arginine, ornithine. Okay, then ornithine transcarbamylase. Okay, these are the like reactions. Ornithine, citrulline, ornithine starting product, ornithine, then citrulline, then arginosuccinate, then arginine, then fumarate, arginosuccinate lyase, urea. Total 4 ATP consumed in this phase. Deficiency of carbamoyl phosphate synthetase. First, hyperammonia type 1. Okay, hyperammonia type 1. Next, phenylalkyl hydroxylase deficiency, phenylketonuria, phenylalanine hydroxylase. Okay, PAH or deficiency, phenylketonuria. Homogentisate oxidase deficiency, alkaptonuria, ochronosis or black urine. Homogentisate oxidase. Tyrosinase deficiency, albinism. Alpha keto acid dehydrogenase deficiency, maple urine syrup disorder, must. Hartnup disease, improper absorption of a tryptophan in intestine. Hartnup tryptophan. Tyrosinemia type first, fumarate acetoacetate hydroxylase and mallyl acetoacetate hydroxylase. Tyrosinemia type 2, Richard Hanhart disease, like tyrosine transaminase. Tyrosinemia type 2, tyrosine transaminase. Next, pyrimidine bases, uracil, thiamine, cytosine. From uracil, sugar, uridine, thiamine, thymidine, cytosine, and cytidine. These are the basic structure of uracil. From uracil, there is two products, thiamine and cytidine. Cytosine, 5-methyl thiamine and 4-amino cytosine. Next, for purine, 9 sugar, BD ribose and osine. Like these are the structure of a purine. Purine base is 3 bases, hypoxanthine, adenine and guanine. In hypoxanthine, 9 on ketone. In adenine, 6 amino purine and guanine, 2 amino purine, 6 on guanine. Sugar, beta D ribose, always attached at 9th position. Hypoxanthine sugar, inosine, adenine sugar, adenosine, and guanine sugar, guanosine. Base plus sugar, nucleoside. Base plus sugar plus phosphate, nucleotide. Nucleotide making method, salvage method, direct nucleotide. Base plus phosphoribosyl pyrophosphate. Okay, and de novo biosynthesis, base step by step plus PRPP. Hypoxanthine to inosine triphosphate, HGPRT enzyme. So hypoxanthine guanine phosphoribosyl transferase enzyme responsible for inosine monophosphate. Guanine to guanosine monophosphate, same enzyme. Deficiency of HGPRT, Lesch-Nance syndrome. Next, pyrimidine biosynthesis derived from three, nitrogen first aspartate, nitrogen third glutamine, and carbon second CO2. Enzyme present in both cytosol and mitochondria. In cytosol, carbamoyl phosphate synthesis second. It's a rate limiting enzyme. And in mitochondria, dihydroorotate dehydrogenase. End product of pyrimidine is beta alanine and beta amino isobutyrate. Orotic aciduria disease, orotate phosphoribosyl transferase and OMP dehydrogenase. Means dihydroorotate dehydrogenase. Okay. Ray syndrome or secondary orotic aciduria. OTC, ornithine transcarbamylase. Ray syndrome or secondary orotic aciduria. OTC, ornithine transcarbamylase. And end product of pyrimidine is beta alanine and beta amino isobutyrate. Purine biosynthesis, N1 aspartate, N3 N9 glutamine, C2 set, N formyl tetrahydrofolate, and C4 glycine. C4 glycine. All enzymes in a cytosol, phosphoribosyl glutamyl aminotransferase, is a rate limiting enzyme. Phosphoribosyl glutamyl aminotransferase. End product of purine is a uric acid. Overproduction, it's gout. And allantoin animals uric acid. It's allantoin breaks uric acid. Substrate level phosphorylation, ATP or GTP release. In glycolysis, glycerate kinase or pyruvate kinase. In TCA cycle, succinyl synthetase. Next, lipids mainly derived from triglyceride and phospholipids. Fats and oils, triester plus glycerol. Fats, saturated fatty acids, and oils, unsaturated fatty acids. Saturated fatty acids, BCC lamps like butyric acid, caproic acid, caprylic acid, and caric acid. So this is BCC lamps. ALMPS, lauric acid, myristic acid, palmitic acid, and stearic acid. After that, arachidonic acid, behric acid. Okay, arachidonic acid, behric acid, able. Unsaturated fatty acids, double bond. Palmitoleic acid, carbon 1 at 9 position double bond. Oleic acid, 18 carbon. Palmitolic, only 16 carbon. Oleic, linoleic, and linolenic are derived from a stearic acid. Those are the 18 carbon. Oleic acid 9, 1 single bond, a double bond. Linoleic 2 double bond, and linolenic 3 double bonds. And arachidonic 20 carbons and 4 double bonds. Chemical test. Salkovsky test, red color, indicates presence of steroids. Salkovsky test, red color, presence of steroids. Lieberman-Burchard test, green color, indicate presence of steroids. Lieberman-Burchard, steroids, green color. Unsaturated fatty acid present, double bond, monounsaturated and polyunsaturated. In fatty acids, cis oleic and trans elladic. Palmitolic acid 16 carbon, 9 position double bond, so delta 9, omega 7 family. IUPAC 9 hexadecanoic acid, 9 hexadecanoic acid. Oleic acid 18 carbon, 9 double bond, delta 9. IUPAC cis 9 octadecanoic acid, omega 9 family. Linolenic acid 18 carbon, 2 double bonds, 9 and 12 position. So IUPAC cis 912 octadeca dianoic acid, diionic acids, omega 6 family. And linolenic acid 18 carbon, 3 double bonds, 9 12 15. IUPAC cis 9 12 15 octadeca trionic acid, omega 3 family. And after that, gamma linolenic acid 6 9 12, omega 6 family. Arachidonic acid 20 carbon, 5 8 11 14. IUPAC 5 8 11 14 ecosa tetranoic acid, omega 6 family. And disease of fatty acids, गाउचर डिसीज, बीटा ग्लूकोसिरेब्रोसिटिस. ओके, गाय चराने समय बेटा गुल्लू के शेर साइड में देखा. गाउचर डिसीज, बेटा ग्लूकोसिरेब्रोसिटिस. नायमन पिक, स्पिंगोमाइलिनस. टेशैच एक्सोजामिनिडिस ए. टेशैच वेरिएंट एक्सोजामिनिडिस ए प्लस सैंड ऑफ. फैब्री अल्फा गैलेक्टोसिडिस. फेवरेट अली गाली दे रहा है, सो फैब्री अल्फा गैलेक्टोसिडिस. Krebs beta galactosidase and Fabry alpha galactosidase, same. And Farber's ceramidase. Fatty acid metabolism, fatty acid oxidation, beta oxidation, alpha oxidation, and omega oxidation. Beta oxidation of fatty acids, activation of fatty acid in cytosol, carnitine transporter in mitochondria, activation fatty acid, beta oxidation. Carnitine means beta hydroxy gamma trimethyl ammonium butyric acids, okay, are called beta hydroxy gamma trimethyl ammonium butyric acids. So these are the structure, alpha beta. End product of beta oxidation is in even chain fatty acid, end product acetyl CoA, and odd chain fatty acid, end product propionyl CoA. Beta oxidation, fatty acyl CoA synthase, thiokinase converted into fatty acyl CoA, activated fatty acids. Acyl CoA in even chain and propionyl CoA in odd chain. So next, cytosol, carnitine, mitochondria. Okay, activated fatty acyl CoA in the presence of hydroxylase, beta hydroxy acetyl CoA, again converted into beta keto acyl CoA, beta hydroxy acyl CoA dehydrogenase. After that, thiolase, 2 carbon less fatty acyl CoA. After that, TCA cycle, acetyl CoA, TCA cycle, and 12 ATP. So next, palmitic acid, 16 carbon, 8 acetyl CoA, and 7 step cycle. So 1 acetyl CoA equal to 12 ATP, and 8 acetyl CoA means 12 into 12 into 8, 96 ATP, and 1 cycle means 5 ATP, and 7 cycle means 35 ATP. So 19 plus 35 or 96 plus 35 is a 131 ATP release and 2 ATP consumed. So for palmitic acid, 129 ATP net ATP, and stearic acid, 18 carbon, 9 acetyl CoA, and 8 step cycle. So 1 acetyl CoA equal to 12 ATP, like that 9 acetyl CoA equal to 108 ATP. So 1 cycle 5 ATP and 8 cycle 40 ATP. So total 108 plus 40, 148 minus 2, 146 net ATP. So palmitic acid 129 net ATP and stearic acid 146 net ATP. So next, deficiency of enzyme, fatty acyl CoA dehydrogenase, SIDS, sudden infant death syndrome, and Jamaican vomiting sickness. So unripe fruit like ackee, toxic compounds, hypoglycin A. Next, alpha oxidation in peroxisomes, branch chain fatty acids, alpha beta branch chain fatty acids. Example, example, phytanic acid, 20 carbon, C20, H40, and O2 contain branch chain fatty acids. Deficiency Repsum disease, enzyme phytanic acid alpha oxidase. Okay, Repsum disease. In peroxisomes, long chain fatty acid, small chain fatty acid. If no, then deficiency Zellweger syndrome, cerebrohepatic renal syndrome, Zellweger. Okay, cerebrohepatic renal syndrome, Zellweger. Omega oxidation at omega position, terminal carbon, medium chain fatty acids, ketone bodies, liver, water soluble, and energy yielding. First ketone bodies, acetoacetate. These are the structure of acetoacetate. Next, acetone. After that, beta hydroxybutyrate. All are in a mitochondrial matrix. Rate limiting enzyme acetyl CoA, acetoacetyl CoA, HMG CoA synthase. Rate limiting enzyme HMG CoA synthase. After that, HMG CoA, beta hydroxy beta methyl gluteryl CoA, HMG CoA lyase, then acetoacetate. Acetoacetate. Liver synthesize ketone bodies but can't utilize because absent thiophorase. Liver synthesize ketone bodies but can't utilize because absent thiophorase. Acetoacetyl CoA, succinyl CoA transfer is absent in a liver. Normal value of ketone bodies 1 mg per deciliter. A Rothera test, detection of a ketone bodies, and fatty acid synthesis stages, production of acetyl CoA, NADH, malonate, fatty acid synthase, 7 enzyme complex, and de novo biosynthesis, acyl CoA carboxylase, acetyl CoA 2 carbon, 2 malonate 3 carbon, acyl CoA carboxylase rate limiting enzyme, biotin magnesium in cytosol, biotin magnesium in cytosol, biosynthesis of cholesterol, acetyl CoA converted into HMG CoA. In HMG CoA reductase presence, convert to mevalonate, and after that mevalonate, cholesterol in cytosol. Okay, these are the biosynthesis of cholesterol. Acetyl CoA, HMG CoA reductase, mevalonate, and cholesterol. Triacylglycerol, glycerol, glycerol 3 phosphate, phosphatidate, and 1,2 diacylglycerol. After that, triacylglycerol, TAG, means triacylglycerol, glycerol kinase, acyl CoA transferase, phosphatidate phosphorylase, and diacylglycerol acyl CoA transferase. Next, structure of proteins. Primary structure, sequence of amino acid stabilized by peptide bond. Number of amino acids means peptide. 2 amino acids dipeptide 1 bonds, 3 amino acids tripeptide 2 bonds, okay, 1 less dipeptide, okay, 1 peptide bonds. Dipeptide means 2 groups, peptide means single bond, okay, 1 peptide bond means 1 linkage, but dipeptide, so 2 group attached with each other. C terminal always at right side and N terminal always at left side. N terminal sequence of amino acid is a Sanger's reagent, Sanger reagent 2,4 dinitro-fluorobenzene, Sanger reagent. After that, Edmonds reagent, phenyl isothiocyanate. After that, Dancil reagent, 1 dimethyl amino naphthalene 5 sulfonylurea. So these are the three agents: Sanger, Edmonds, and Dancil for N terminal. After that, C terminal Slack-Kump method, C benzylation. Primary structure of protein is not affected by denaturation. Okay, primary structure of protein is not affected by denaturation. Secondary structure of protein: main bond, hydrogen bond, configuration, conformation, twisting, and folding. Alpha helix, right-handed, more stable, intramolecular hydrogen bond. Beta plated, intermolecular hydrogen bond. Alpha helix, intramolecular, okay, and beta plated, intermolecular. In proline immuno amino acids, no alpha helix. Tertiary structure of protein: 3D configuration and conformation. Disulfide bond, main bond in tertiary structure. Disulfide bond, main bond in tertiary structure. Hydrogen bond, electrostatic bond, and hydrophobic bond also present. But main bond, disulfide bond. Quaternary structure, okay, quaternary structure for their shapes, okay, same like that. After that, test for proteins, biuret test, minimum 2 peptide bonds, tripeptide, 3 amino acids. बाय कपड़ा साफ कर रही है वायलेट कलर का. बायोरेट टेस्ट, अल्कलाइन कॉपर सल्फेट, वायलेट कलर. मिलन्स टेस्ट, टायरोसिन फिनोलिक ग्रुप, मर्क्यूरी नाइट्रेट, ब्लड रेड कलर. मिलन्स टेस्ट, टायरोसिन, ओके, फिनोलिक ग्रुप. मिलन्स टेस्ट, टायरोसिन फिनोलिक ग्रुप. नीनहाइड्रिन टेस्ट, नीनहाइड्रिन प्लस अल्फा अमीनो एसिड्स, पर्पलिश येलो, पर्पलिश ब्लू, and नीनहाइड्रिन प्लस इम्यूनो अमीनो एसिड्स, येलो कलर. xanthopoietic टेस्ट, बेचारा जानी, बेंजीन, फिनाइल एलानिन, टायरोसिन और ट्रिप्टोफैन. जिस भी ड्रग में बेंजीन है उन सब के लिए xanthopoietic टेस्ट होती है. फिनाइल एलानिन, टायरोसिन एंड ट्रिप्टोफैन. नाइट्रिक एसिड येलो कलर, सो बेंजीन. नाइट्रिक एसिड येलो कलर. हॉपकिंस कोल, इंडोल एंड ट्रिप्टोफैन. होफे कल इंदौर जाते हैं ट्रिपर. इंडोल एंड ट्रिप्टोफैन के लिए हॉपकिंस कोल. साकागोचे, गोनेडिन, अर्जिनिन. और नाइट्रोफोसाइट टेस्ट, सल्फहाइड्रिल. नाइट्रोफोसाइट टेस्ट, सल्फहाइड्रिल. पाउली टेस्ट, इमेडाजोल, हिस्टिडिन. पाउली टेस्ट, इमेडाजोल, हिस्टिडिन. पाउली टेस्ट, इमेडाजोल, हिस्टिडिन. So next topic is sterilization. Sterilization, static plus saddle, and disinfection, static plus saddle. But in sterilization, kill spore and vegetative form. In disinfection, kill only vegetative form. Microbes, spore form, sexual form, responsible for reproduction, more dangerous. And vegetative form, only self growth. Antiseptic action, only vegetative form, get killing on a living skin surface. And microbial death kinetics, 3 parameters: D value, F value, and Z value. So D value, decimal value 0.1, 1 by 10. 100 microbes convert into 10 microbes. So how many times required for convert into 90% reduction? That's called D value. D value is the time. It is the time taken to achieve 90% reduction in microbial population at given temperature. Temperature is inversely proportional to time exposure. जितना टेम्परेचर ज़्यादा उतना टाइम कम लगेगा. Z value, 100 microbe converted into 10 microbe in 10 minutes. ओके, इनिशियल D वैल्यू. आफ्टर दैट हमें ऐसा कितना टेम्परेचर बढ़ाना है जो कि हम 10 मिनट को 90 मिनट्स, मतलब 10 मिनट्स को 1 मिनट्स में कन्वर्ट करें. उसको बोलते हैं, उस टेम्परेचर को जितना टेम्परेचर हम बढ़ाएंगे उस टेम्परेचर को बोलेंगे जेड वैल्यू. 1/10 reduction in d value, 100 microbes in a 1 minute, 10 microbes. Okay, final d value. So z value is connoted units degree Celsius, degree Fahrenheit, degree Kelvin. Z value is the increase in temperature to achieve the 90% reduction in a d value. Z value thermal resistant value. Okay, temperature. Thermal means temperature. F value other than 90 degree, same as a d value, but d value is for 90% reduction. F value is other than 90, means 80 or 91, anyone's. 80% reduction in microbial population. How much time? F value, factors of a d value. F value is the time required for reduction of microbial population other than 90%. They either may be 45, 60, 91, anyone's. Sterilization is pursued to achieve complete removal of all viable microorganisms. Viable means living and reproduction. Disinfection, killing vegetative form of a microorganism. Exposure time is inversely proportional to temperature. These are the basic methods. Exponential phase, lag phase. Okay, cooling phase means these are the uh, four phases: lag phase, log phase, also called exponential phase, static phase, and denaturation means death phase. Okay, death phase, also called death or log phase, lag phase, log phase, also exponential, static phase, and death. Sterilization, thermal methods and non-thermal methods. In thermal methods, dry heat, moist heat, and low temperature sterilization. In low temperature, ineffective against spores like pasteurization. And direct flaming, incineration are the thermal methods. And non-thermal, filtration, radiation, and chemical. So incineration, product like cotton, cloth, metal foil directly convert into ash. Direct flaming, nichrome wire, inoculating loop. Okay. After that, dry heat sterilization, dry absent moisture, materials greater than 140 degrees Celsius stables. Example, glasswares, metalwares, oil formulations, dry powders. Okay, dry heat sterilization. Mechanism, thermal, oxidation, dry heat, microbial proteins denaturation. Okay, oxidation, microbial proteins denaturation, oxidation, dry heat, thermal. Equipments used in dry heat sterilization, tunnels and hot air oven, mainly hot air oven made by stainless steel. These are components not important. Okay. Next, indicators in dry heat sterilization, evaluators means indicators. Physical thermocouples also used in a moist heat. Chemical Brown's tube, chemical fixed temperature color change. Okay, indicators. Biological microscope pores, Bacillus subtilis. Okay, these are the dry heat sterilization, Brown's tube, thermocouple, and Bacillus subtilis. Next, low temperature sterilization, also called marginal, less than 100 degrees Celsius, ineffective for spore. Exception, ultra pasteurization. Okay, ultra pasteurization temperature is a 140 degrees Celsius. So there is three methods: tip like tyndallization, incipation, and pasteurization. These three are the marginal methods. Marginal means fractional, like 3 days. Tyndallization 80 to 85 degrees Celsius, 50 minutes, and incipation, incipation 60 degrees Celsius, same, 50 minute. 15 minute, 15 minute. Remember time, 15 minute, 15 minute. But tyndallization 80 to 85 degrees Celsius, incipation 60 degrees Celsius. Pasteurization, low temperature, longer time, also called Holder method, 62.8 degrees Celsius for 15 minutes. High temperature short time, also called flash method, 78.8 degrees Celsius for 15 seconds. Okay, and ultra pasteurization means 140 degrees Celsius for 3 to 5 seconds only. So remember pasteurization. In tyndallization, temperature 80 degrees Celsius for 15 minutes. In incipation 60 degrees Celsius for 15 minutes. In pasteurization, low temperature, longer time, high temperature, short time. Ultra pasteurization is a 140 degrees Celsius for 3 to 5 seconds. And low temperature, longer time, Holder method, 62.8 for 15 minutes. Same like incipation and tyndallization. and high temperature short time 72 78.6 degrees Celsius for 15 seconds. Okay, 78.6 for 15 seconds. After that, moist heat sterilization based method autoclave. Okay, maximum temperature 134 degrees Celsius. Moisture plus heat, vapor steam, quick damage. Boiling water, slow damage, but vapor, quick damage. 1 calorie equal to 500 calories, so these are not very much important. 1 mole of steam, 100 grams of water. Okay, 100 degrees Celsius, 9720 calories. These are the important factors. Next, mechanism thermal sterilization, coagulation, moist heat water, hydrolysis of a peptide bond, microbial protein denaturation. In dry heat, oxidation, and in moist heat, coagulation, hydrolysis of a peptide bond. Instrumentation, autoclave, temperature, mainly temperature is a 121 for 15 minutes, 15 pressure as a best. Okay, 121 degrees Celsius for 15 minutes and 15 TBS. If temperature increase, time decrease. Okay, temperature in decrease, time increase. So 115 for 30 minutes, 121 for 15 minutes, 126 for 10 minutes, and 134 for 3 to 5 minutes. Indicators physical thermocouples, same as dry heat, chemical autoclaving, Bowis dick and helix test, coloring dye heat sensitive, and which dry heat Brown's tube, but here is Bowis dick and helix test. uh, Example: vitamins, steroids, serum, emulsions, protein formulation, hormones, vaccines, toxins, not sterilized by moist heat sterilization. Aqueous formulation, rubber closure, aqueous formulation, rubber closure, Dacron, nylon, glasswares, metalwares by moist heat sterilization. Okay, aqueous formulation, rubber closure, Dacron, nylon, glassware, metalwares. Non-thermal sterilization, filtration, radiation, and chemical. Radiation sterilization, non-ionizing UV rays and ionizing gamma rays and beta rays or cathode rays. Natural gamma rays are naturally and man-made beta rays. UV rays weak intensity used only for surface sterilization. Intensity is inversely proportional to distance square. UV light lambda range 200 to 400 nanometer. Maximum sterilization 273.5 millimicron, 273.5 nanometer, and 2735 angstrom. So after that, safety limit for human exposure UV intensity 2.4 microwatt per centimeter square 1 hour. UV mechanism interact with electron, UV light energy electron ground state to excited state, microbial electron reactivity alter, microbes metabolism alter, microbial death. Source in UV mercury lamp. After that, ionizing radiation, uncontrollable gamma rays radioactivity, and beta rays cathode rays high accelerated electron. Source cobalt 16 and cesium 137. Cobalt 16 and cesium 137. Source Van de Graaff generator up to 3 micro electron volt and linear accelerometer up to 10 to 15 micro electron volt. After that, disadvantage: if more than 10 micro electron volt radiation, radioactivity induce million mega electron volt. Okay, million mega electron volt. Indicators physical in ionizing dosimeter device and biological radiation, Bacillus pumilus, Biospherons, and Micrococcus radiofena. So important is indicators. Dosimeter device in ionizing radiation. Filtration, heat susceptible, heat susceptible gas, liquid fluids, thermolabile substances, vaccine vehicle, not vaccine, fluids, liquid sieving, and gases, HEPA filters, function friction, filter pore, electrostatic alteration. Filters in first sintered material, glass, Scott Duran, and stainless steel. Membrane filter polymers mostly used. So size of membrane filters 0.2 micrometer pore size. After that, hydrophilic cellulose, cellophane, cellulose acetate, cellulose nitrate, nylon 66 ultipore, PVDF, polyvinylidene difluoride, hydrophobic Teflon, polytetra polyethylene, PVDF hydrophobic surfactant, PVDF hydrophilic indicator, physical indicator, point bubble point pressure test. Bubble pressure is inversely proportional to pore size diameter. Bubble point pressure test, evaluation of a membrane filters. Biological indicators, diminuta, Pseudomonas diminuta pore size or Bravendomonas diminuta. Next, chemical sterilization, alkylating agent and oxidizing agent. In alkylating agent, beta propiolactone and ethylene dioxide, okay, diethylene oxide, a highly volatile room temperature gas, highly inflammable, in presence of air oxygen mixed with fluorocarbons. Oxidizing agent, hydrogen peroxide, sodium hypochlorite per acetic acid. Procedure, material kept for 60 minutes at 98 degree percent relative humidity, increased permeability of microbes, preheated chamber at 55 degrees Celsius, base sterilization, create vacuum 27-inch Hg, release ethylene diethylene oxide gas, add in last 27-inch Hg vacuum, oxygen out, ethylene dioxide in. Okay. Next, beta propiolactone, less volatile, non-inflammable, room temperature liquid, less ineffective. Effective. Disinfection. Evaluation of disinfection, standard infection with phenol. Phenol coefficient test, suspension test, Riedel alcohol test, Salmonella typhi, outer use medium. Riedel alcohol test, Salmonella typhi. And for capacity test, Kelsky skies test and Chick Martin test. In Kelsky skies test, triple challenge test and Chick Martin test, Salmonella typhi and Staphylococcus aureus, yeast medium, human feces. So these are the sterilization.